All right, let's answer the first two questions, and then we're going to go enter this data and see what we're going to do with it. So number of pairs of shoes. Is that a categorical or a quantitative variable? Quantitative. Last couple of days, we've been dealing mainly with categorical variables. So now we're going to kind of switch the discussion. Today, tomorrow, Thursday, we're going to talk about quantitative variables. Can this variable have decimal values? No. I mean, unless you are in the habit of cutting your shoes into pieces and then wearing those pieces. So we can't take decimal values here. When we can't take decimal values, we call that a discrete variable. D-I-S-C-R-E-T-E. With a discrete variable, we have no decimals. If we can take decimals, we call that a continuous variable. So number of pairs of shoes would be a discrete variable because you can't have decimals there. But running time in the Olympics 100-meter dash, that would be a continuous variable because they don't just measure it down to the second. They don't even just measure it down to the millisecond. They've got that stopwatch running with nanoseconds on there. So it can take on any possible value. There's no values that you would say, no, that doesn't make any sense. All right, we're going to take number of pairs of shoes. I'm going to enter it into StatsMetric, which when I pull this up, it takes me to a site called Statlet. This is something that we're going to be using in here, so I want to kind of walk through how I know which one I'm choosing, because this isn't the most user-friendly interface here. You guys told me we were working with a quantitative variable, right? How many quantitative variables did we have? How many questions were asked? One. You reported back how many numbers? One. We collected a whole bunch of data, but we collected one piece of data from everybody. We have one quantitative variable, and we're going to do that for a single group, just this class. So one quantitative variable, single group. This is where I'm going to go. Variable name. We want to be specific here. What was it that I asked you about? Number of pairs of shoes. So that's what I'm going to type in here for our variable name. Number of pairs of shoes. We're going to enter the raw data. So I'm going to come over here to the poster. I'm going to type in every single number separated with a comma. We've got 4, 10, 8, 7, 8, 11, 2, 3, 22, 7. That's a 65 or 63? 65, that's what I thought. 65, don't be embarrassed. I got the exact same number. 2, 16, 4, 3, 11, 7, 4, 9, 11, 9, 9, and 5. All right, so I've got all the values from our poster over there, and I'm going to begin analysis. So the first thing that shows me is a dot plot. This is what I want you guys to put on your number line there. You have to decide where you're going to start counting from. Like, are you going to start at 5? If so, you're going to need to extend it over a little bit because we had some people with 2. So you might need to extend your number line to the left or to the right to fit everything on there. I'm going to count by 5s on mine and just extend either way. Go ahead and copy that onto your page. All right. Can I get a hand if you're still working on your dot plot? Okay, I won't scoot on to the next piece yet. I love this data set, by the way. Some things that I want to point out while you guys are finishing up your dot plots individually, and that is this down here where it gives me my summary statistics. Summary statistics, first thing that tells me is N. N is the number of pieces of data that we collected. So there were 23 people that told us their pairs of shoes, so N is 23. It has calculated the mean for us already. What's the mean? The average. How do you calculate it by hand? Add them all up and divide. So I would have to add all the numbers on that poster and then divide by 23. That would give me this 10.304. This one here we'll talk about on Thursday. This is my standard deviation, or sorry, we'll talk about that one tomorrow. Don't worry your head about it right now. Minimum was 2. Maximum was 65. We'll talk about these pieces here, except I do want to point out this one, the median. What is the median? The middle. How do you find the median? You cross out the ends. So I could find the median from my dot plot here because I could cross out, like I could cross out my 2 smallest ones here and then cross out the 2 biggest ones here. Cross out the next smallest one and the next biggest one. Next smallest, next biggest. 1, 2, 3 small ones, 1, 2, 3 big ones. 1, 1, 1, 2, 3, 1, 2, 3, and I'm left with this right here. So you could cross out to find that. When you use a dot plot to do your crossing out, on the small end, you start at the bottom and work your way up. On the big end, you would start at the top and work your way down for anything that has more than 1 dot. So far, so good? All right, let's look at the next type of data display. This is a little bit below your number line, and then over on the left-hand side, we're going to do what's called a stem and leaf plot. This is what our stem and leaf plot looks like. Notice there's gaps on here. There's nothing after the 3. There's nothing after the 4. There's nothing after the 5. We wouldn't put a 0 there, because if I were to put a 0 after the 3, then I'm saying somebody reported 30 pairs of shoes. Yes.
Do you think you could like slow down?
I really wish I could. I can read them off for you. On this particular one, I cannot. I am so sorry. All right, so this row here where we start with 0, 2, 2, 3, 3, 4, 4, 4, 5, 7, 7, 7, 8, 8, 9, 9, 9. Does anybody need me to read that row again? All right, going to the next one down, it's 0, 1, 1, 1, 6. And then here by the 2, there's a 2. And down by the 6, there's a 5. And then you have a spot on your page for the key as well. 6 and then /5 means 65. We'll talk about all of these here in just a moment. I just want you to get them copied down on your page so that then when I'm talking about it, you have room to add the extra notes that we're talking about, and you're not busy making your graph then. You guys ready for the last one? All right. The last type of visual display is a histogram. So here's what our histogram looks like. Looks like here in this program, they've decided to count by 2s on that vertical axis so that I can fit all the information on. I'm also going to count by 2s. And then down on the horizontal axis, it looks like they're counting by 10s. All right. Does anybody need me to leave this up? Okay, I'm happy to leave it up a little bit longer. One of the things I want you guys to notice about the histogram is that there's no gaps between the bars. When we're doing categorical data and we do a bar graph, there's always gaps in between the bars. When we do a histogram, there are never gaps between the bars unless there's a gap in the data. Like there's a gap between 30 and 60 here in our data because we didn't have anybody with pairs of shoes between 30 and 60. But that's the only time you would see a gap on a histogram. Bar charts are always going to have a gap in between the bars. This is one visual way that you'll know whether you're being presented with categorical data or quantitative data. If the bars are touching, it's quantitative. If they're not, then it's categorical. Right? You okay if I switch over? Okay. All right, so I've got all those plots up here. So we've got our dot plot. Let's go ahead and actually label that as a dot plot. Notice they've labeled the horizontal axis number of pairs of shoes. If a label is not provided or you are hand making the entire graph, you do need to provide a label for that. Notice all of ours have labels. On my stem plot, this is called a stem plot or a stem and leaf plot. We have it labeled down here, number of pairs of shoes. This should show the gaps in the data. So on a stem and leaf plot, these values over here, which is always the last digit, are our leaves. And anything that is not the last digit goes over here and becomes part of our stem. It's okay to have 2-digit numbers over here on this side. Like if somebody had come in and said, I have 120 pairs of shoes, we would have a 12 on this side of the line, and that would be okay. On this side over here, single digits only, 0 through 9. This stem and leaf plot is one way of having a visual display that's a lot like a histogram, but still shows me all of the raw data. When I'm looking at my histogram over here, I can't tell you that somebody said they had 5 pairs of shoes or that there were 3 people that said they had 7 pairs of shoes. I can't see that in this, but I can see that in my stem and leaf plot. And then we have our histogram over here. I noted that there's no space between the bars. We show our gap here. And now there's only one other big issue that we would need to talk about with making a histogram by hand. If I make a stem and leaf plot by hand, I take everything that's not the last digit and I list it in order, including anything that got skipped as my stems. Notice I still included 3, 4, and 5 on here, even though nobody said 30, 40, or 50. So you start with your smallest. In this case, it was 0 because we had some 1s. These can also be decimal values, which is why the key is really important. Depending on what we were talking about, 6.5 might make sense as a value. When we're talking about number of pairs of shoes, we can't have decimals, but decimals are possible on certain things that we might want to report with a stem and leaf plot. So you have to show what your stem is representing and what your leaves are representing. In this case, our leaves are representing the ones place. Notice how we have our horizontal axis. I've labeled mine by tens. We call which bar you would go into a bucket. We have to decide. We had somebody who said they had exactly 10 pairs of shoes. They fall right on that dividing line, right? So do I put them in this bucket or this bucket? Second one. Standard practice in statistics is that if you have a value falling right on the dividing line for a histogram, you put it in the next larger bucket. You put it with the larger numbers. So this right here includes the 10. All right, so these are the three main visual ways that we have of representing quantitative data. Dot plot, stem and leaf plot, and a histogram. And we have this so that we can get some sense of what our data looks like. When I collected the number of pairs of shoes you guys own over here, I have no idea whether most of you guys are in the low numbers or whether a lot of people are in the high numbers. I mean, I only see the 165, but this isn't a very good way for my brain to take in a lot of information quickly. Once we present something visually, if I'm looking at the dot plot, I can see really fast at a glance that most people in this class have 11 pairs of shoes or less. I can see the same kind of thing when I'm looking at my stem and leaf plot. I see that most people have somewhere between 10 and 20 pairs of shoes. Same kind of thing here with my histogram. I get a lot of information. I know where most people in this group are very quickly at a glance. When we talk about data sets, we often want to describe what the distribution looks like. So let's look at these questions. If I were to ask you, how many pairs of shoes does the typical student in our class own? Looking at this, what would you tell me? 4, 7, or 9? What about if I asked you to like nail it down a little bit more? You said 9? Does anybody remember what the median was when I had it up on the screen? 8. So 9, 8, 8 is our median. I would go between 8 and 9. So let's go ahead and say about 9. All right, describing the distribution. We are not going to get all the way through this today before the bell. We're going to have to finish this up tomorrow. Of the number of pairs of shoes, we have to have context when we are describing distributions. The overall shape of the data, let's look at the histogram because I feel like that's the easiest one to look at. How would you describe what this histogram looks like to somebody? Like, say you're on the phone with them, you can't FaceTime with them, and you're trying to explain what this graph looks like. How would you describe it? What'd you say? Descending, so more on the left than on the right? Absolutely. Okay, so more data is clustered on the left than on the right. How many clusters of data do you see? How many like large bumps in the data do you see? Really one, right? Like this one kind of looks like it's sloping up to this high point. But we don't have like another big bump of data over here. It's not like we had some small little group that they're like, we all have a ton of shoes, and so we'd have another bump of data over here. So we have just one main bump of data. When there's one big bump of data, we call that unimodal, meaning one. If there is more than one peak, we say it is multimodal. Does anybody remember what the mode is? Like mean, median, mode? The number that shows up the most. So that's why when I have two bumps of data, we say it's multimodal or bimodal, because there's two areas that have the most. Okay. And then talking about, is there any other interesting features here? Or is all the data pretty much clustered together in one spot? There's like one big gap here, right? And then we've got this other piece of data over here. It's not a bump of data, but we do have this other piece of data over here. So things that I would want to make sure to mention if I'm talking about the shape. I would say that this is skewed right. I'll explain what that means here in just a second. Unimodal. There's a gap between 30 and 60. We'll talk about these other pieces, outlier, center, variability, tomorrow. When I say it's skewed to the right, notice it starts high and it slopes down and it kind of has a tail out to the right-hand side. That is skewed to the right. If my big bump of data is on the left, is on the right, and it has this tail that trails out to the smaller values, we say it's skewed left. If it looks about the same on the right as it does on the left, then we say it is symmetric. And we will finish up our descriptions tomorrow. We'll do the back side of that page tomorrow. You guys do have a reading assignment that I need you to do for tonight, pages 30 to 46. 30 to 46.